Subtopic 4.3. Compute the inverse of a non-singular matrix using adjoint matrix, elementary row operations, and use the property of AB equals to KI. Inverse matrix. Inverse matrix. Let A be a square matrix, then inverse of A is written as A inverse. Not every square matrix has an inverse. When a matrix has an inverse, it is said to be non-singular. If it has no inverse, it is called singular. Determine whether matrix B is an inverse matrix of A. Note that matrix A multiplied with matrix A inverse is equals to identity matrix. AB is equals to identity matrix. Therefore, B equals to A inverse. Adjoint method. Let A be a square matrix. Adjoint A is defined by transposition of cofactor matrix A. Inverse of A can be found by using A inverse equals to 1 over determinant of A times adjoint A, where determinant of A cannot equal to 0. Inverse of 2 by 2 matrix. Find the inverse of matrix B by using adjoint method. First, we need to find the determinant of matrix B. As the determinant of matrix B is not equals to 0, therefore B has an inverse matrix. Adjoint B is cofactor transpose. Then we get B inverse. Alternative method. Inverse of 3 by 3 matrix. Given matrix B, find B inverse by using adjoint method. First, we need to find determinant of matrix B. Adjoint B is equals to cofactor transpose. Then we get B inverse. Inverse properties. Property of AB equals to KI. Given matrix A and matrix B, it is known that AB equals to KI, where K is a constant and I is 3 by 3 identity matrix. First, we need to find the value of K, and hence we need to deduce A inverse. AB equals to 2I, therefore K is equals to 2. To deduce A inverse, we need to use AB equals to 2I. We multiply both sides of the equation with A inverse. Then we get A inverse. Elementary row operation, ERO. 3 types of operations which apply only to rows of a matrix. Steps to get an inverse by using ERO. Let A be a square matrix. The inverse matrix of A can be found as follows. write A and I side by side to form the augmented matrix. Use elementary row operation to transform A into I. The resulting matrix on the right is A inverse. Find the inverse of matrix A by using ERO. First, we need to form the augmented matrix. The idea is to change all the non-diagonal entries to be 0. If we want to change the second row, we have to remain the first row. The new second row will be 4 row 2 minus 3 row 1. If we want to change the first row, make sure we remain the second row. The new first row will be negative 1 row 1 minus 3 row 2. Next, we want to change all the diagonal entries to be 1. If we have the identity matrix in the left-hand side, the right-hand side will be the inverse matrix. Then we get A inverse. Inverse of 3 by 3 matrix by using ERO. Find the inverse of matrix D by using ERO. Find the inverse of matrix B by using ERO.